Captain Peter Cutsie, South Korea, and this is my briefing room. Part two of the go-around procedure, we're going to have a look at the ASAGA findings. ASAGA, airplane state awareness during go-around, studies that were made in Europe, and very interesting that we have a look at the findings. The French Authority for Safety Investigations in Civil Aviation observed that a number of public air transport accidents or serious incidents were caused by a problem relating to airplane state awareness during go-around, which may otherwise be described as a loss of control of the flight path during or at the end of a go-around maneuver. Other events revealed inadequate management by the flight crew of the relationship between attitude and thrust, with go-around mode not engaged, but with the airplane close to the ground and with the crew attempting to climb. These events seem to have some common features, such as the startle effect, the phenomenon of excessive preoccupation by at least one member of the crew, poor communication between crew members, and difficulties in managing the automatic systems. A study was thus initiated with a view to list and analyze the factors common to these events and suggest strategies to prevent their recurrence. In all the years I've been flying and teaching, I have really gone around less than 10 times. That's in 62 years of flying and in instructing and in a simulator as far as myself, my own proficiency is concerned. So really, the startle effect is very true. Whether you go around because you don't see enough to go around, or whether you're going around because you're directed to go around by ATC, normally it's not what you've expected. So let's look at some of the study. Analysis of accidents and serious incidents due to go around show that crews are often no longer aware of the basic parameters, pitch, thrust, and their correlation with changes in calibrated airspeed and vertical speed. What's happening to them? Performing the go-around requires a high number of actions. Crews may have difficulty in identifying priorities for their actions and may not continuously monitor these parameters. Neither the procedure nor the training in its use stipulates that the crew go back to these fundamental parameters, pitch and thrust. These are basics of flying. If your pitch is correct and your thrust is correct and you're monitoring these two parameters, you should never get yourself into any kind of trouble. Assessment of the role of the pilot monitoring. And remember, I like to call the pilot monitoring as the pilot flying in standby. The performance of the monitoring function is essential, but insufficient during the go-around. During performance of the go-around study, these are studies that this group have made, the pilot monitoring's attention was focused on the actions to take and not on their monitoring. It is therefore necessary to focus of this issue. Cockpit resource management. The ASAGA study highlighted the difficulties of maintaining a good level of CRM throughout the go-around. The priorities of the pilot flying and the pilot monitoring are different. Their respective workloads limit their interaction and mutual monitoring of actions. We'll talk more about that when we get into the actual part 4 of this series. Flight crew training. The study showed that pilot training did not correlate with the scenarios of accidents and serious incidents due to go-arounds, especially during recurrent simulator checks. Competence-based training, event-based training, these new terms have to be part of the future of our training organizations. The use of cameras in a simulator to actually record what people are doing, not just what the crew members are doing, but what the instructor is doing and what the instructor is not doing. We need super instructors in order to prevent incidents and accidents. Limitations on available thrust. Do we know the limits? When full thrust is used during a go-around, an excessive climb speed can be reached very quickly, as I mentioned in part 1, and make it difficult to undertake the actions in the go-around procedure. It can firstly be incompatible with the time required to perform the go-around, and secondly be a source of the somatographic illusions. Somatographic illusions are what you think is happening, but what isn't happening, what you feel is happening, but you're not believing your flight instruments, you're going by your feelings. These illusions that have led crews to make inappropriate nose-down inputs. Certain manufacturers have already implemented a system limiting the thrust. Well, we have that on the 737. Selecting Toga for the first time gives you a limited amount of thrust, actually 8% gradient, which equates to 1,000 to 2,000 feet per minute. Pushing the Toga switch a second time will give you the full N1 thrust of that engine. And that's something you don't want to do unless it's required. The main objective is to give flight crews time, limit excessive sensory illusions and excessive pitch attitudes. The study showed that there is a conflict between the application of maximum thrust and an operating environment that rarely, if ever, requires it. If you were into a wind shear, you're going to discontinue the go-around procedure and you're going to do the wind shear escape maneuver. And that's important that you know the difference. And I made that point very clear in my wind shear video briefing. Engagement of automated systems and monitoring modes displayed on the FMA. They're changing rapidly during a go-around. So you have to know your airplane. And in part 1 of this series, I explained a little bit of ground school review. The study showed that the number of changes in the FMA modes during the go-around can be high. This makes it difficult for the crew to detect and read all the changes. Go-around procedures cannot be evaluated based solely on the assumption that the FMA mode changes have been comprehensively read and understood. In addition, the selection of a proper guidance mode displayed on the FMA does not guarantee correct tracking of the path. Go-around procedures need to be evaluated in realistic operational context. Manipulating the MCP. As I mentioned before, I know your SOPs state that when an autopilot is engaged, the pilot flying will make all MCP inputs. Not necessarily correct. You have to feel comfortable. And this was brought out, this very fact that I mentioned in many of my briefings already. During a go-around, the attention given to manipulating the MCP can take a long time, during which the flight path is no longer monitored. The pilot flying has an autopilot engaged, and he or she is up on the MCP trying to understand what's happening as the FMA is changing. What happens to the airplane? Most crews manipulate the MCP without observing the results on the EPIS. Everything's done in threes in the airline. When you push a button on the MCP, you push the button, a light comes on, and then your eyes go to the FMA. So you push, you observe the light, and then you go to the FMA. 1, 2, 3. Basic. Many people don't. I know. I've been watching it in the simulator day after day. people just pushing the MCP and not really looking to see if they're getting a response that they should get on the FMA. Airplanes are smart. Boeing's smart. They build a beautiful airplane. But we as pilots have to know our airplane, meaning we have to study a lot. All right. So go around and position a pitch trim. A go around performed at low speeds with unusual nose up trim position can lead to small, or to a stall, I should say, and a loss of control. Crews pay less and less attention to the position of the trim during flight. It's something you should be watching as your weight is changing, the autopilot is trimming. And is that trim wheel moving when it should be moving, or is it moving when it shouldn't be moving? Runaway stabilizer trim, I really think, should have been labeled in the QRH as an unscheduled movement of the stabilizer trim wheel. We hear the chunk, 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 but our brain doesn't register. We think, oh, it's normal. This is happening because the aircraft is trimming. But really, when it goes chunk, chunk, chunk and doesn't stop doing it, it takes a long time, I find, for pilots to notice the fact that it's a runaway stabilizer. So think of the runaway stabilizer trim QRH listing as being an unscheduled movement of the stabilizer trim wheel. If you think of it that way, you won't get caught doing nothing when you should be doing something, especially close to the ground. All right. Remember, we talked about this in part one. If you're doing a dual channel approach with two autopilots for an auto approach and landing, remember that the autopilot trims nose up twice, once at 400 feet RA and once at second time at 50 feet. Well, that little nose up trim is there to help flare and touch down automatically. But if you have to go around and you're in the go around mode later, and you are you actually wonder why the FMA is not indicating an altitude acquire, it's probably because the aircraft is mistrimmed. So recommendation is to disengage the autopilots and manually trim the aircraft and then re-engage a single autopilot suggestion. So few pilots know the upset recovery, by the way. So applying full thrust can lead to an excessive nose pitch up that can be uncontrollable. Few pilots know the upset recovery and procedure, which consists of reducing the thrust and or modifying the trim position. Modification of go-around flight paths by ATC. ATC can modify the published missed approach procedure during the go-around maneuver. Crews can then be surprised or even upset to have to change their plans of action during a go-around. And remember, go-around for air traffic control, they've probably witnessed more and more variables, and they're working with all different types of aircraft. So it's really a startle effect for them to, at the last minute, have to issue you something different in a go-around. The consequences of these changes can be significant, particularly when they prevent the use of certain automated systems and increase the time pressure. In a flight phase where the workload is already high, additional actions disrupt teamwork and monitoring by the pilot monitoring in particular. I've often said, and I really firmly believe, that the toughest job on board an airplane or position on board an airplane is not that of the pilot flying. It's that of the pilot monitoring. It's a much more important job. As a captain, if I had a problem, when I did have problems, I always gave control to my first officer because I wanted to be the pilot monitoring. I wanted to read the checklist. I wanted to have an overview of what was happening. So in actual practice and experience, pilot monitoring really has a much more detailed assignment. That's why, incidentally, we changed the actual name of pilot not flying years ago to pilot monitoring, because in simulator sessions, we found that the pilot flying once she or he was finished their half of the simulator session and came in for the second half when they were acting as pilot monitoring, they were next to useless. Oh, well, I'm not flying now, it's not my turn. No such thing as not my turn. CRM, you're one on board an airplane. Captain and first officer, think as one. That's why I'd like to rename that position of pilot monitoring as pilot flying and standby. Cabin pressure controller 1, cabin pressure controller 2. They're both identical. Think of it that way. Design of missed approach procedures. Well, the design of procedures really, and that's part of the airport authorities and governments to make sure that they design procedures that are reasonable. And it may be better to choose higher altitudes rather than altitudes too close to the ground. All right, so that is that. That's the end of part 2. We're going to go on to a very interesting AFDS notes that I've made. I want to show you in part 3. I hope you enjoyed the briefing. See you in go around part 3.